All right, let's begin. Our water source is at approximately 82 feet. So we're going to work with these rough numbers for now until we get exactness. So 82 feet. Now this is 82 feet above sea level. And that's not very horizontal, but we're going to work off of that for right now. The water, as it comes into the system, you can go to pressure.greatgizapyramid.com, or if you don't like to type a lot, pressure.giza.com. And you will see that where the first of the structures that we come across, it's got its way, and we're just going to, things that are definitely there. The opening comes in. Actually, if I'm going to do this, yeah, no, that's right, it comes in. You got your Archies here to put the eye on this. This right here, the water level, 82 feet, is going to be right here. Okay, that's going to be our 82 feet. And this right here, this is 79 feet. This lip right here, the bottom part of this opening here is 79 feet, which makes the air outlet at 79 1/2 feet. So we'll put 79.5 out is, I'll just put air out for right now. We know that's actually, I'm going to label it as what I believe it to be. Well, it's my system. I'm building it. It's my system. I know what it is. So that is oxygen, O2, out at 79.5 feet. And that is the elevation of that right there. Okay, and you can pull this picture up by going to photos.greatgizapyramid.com. I'm not trying to hide anything from you. I want you to put eyes on it so you can see it yourself. When you go to these structures, you will understand why all these pieces are here. And what I'm going to ask you now is, if you have the opportunity to get there, you and the person you're with, take your little cell phones, because you'll have to take pictures now. Stand at this point, hold your cell phone, do the GPS coordinates, take a screenshot, take Google Maps where you're standing, take a screenshot, do the bit on your phone where it tells you your elevation, take a screenshot, and then using the other camera, back away from that at any point, showing one of those, and show where you are so that it documents your location and that number. And I'm going to use all these points to fine tune this so that when we actually get working at this, we'll know the exact pressures, because the difference when we're looking at something which is a square mile in size-ish, when we're looking at the entire plateau, over that distance, a ½ inch will matter which way things flow because of the weights of the objects, elements, compounds that we're talking about within the system. Now I'm babbling a bit, but you'll understand more as we go on. Anyway, so that comes down. It actually comes past the flat point and then comes over, and then that is kind of the opening, right? We can agree on that. And if you go to saw my video on the this area here, we can all agree that there is a center over here that is 9.6 meters or something in size back there, and it comes lower and lower to the ground. Now this here that goes down and connects with this feeder at that 79 feet, that's your water inlet, which the water will come and equal out with that water within the system, and it will be there. Babbling a bit, but the gas, in this case I'm suggesting the oxygen, will have to fight below, kind of like when you push a beach ball under the ground. It's going to build up pressure to bubble out. Oh, I'm sorry, the water inlet, that's actually right up here, and that's about a foot difference. So this is actually the water inlet. That's the water inlet. that is actually at, since it's about a foot difference, I'm going to say 81.5. And that is the water, so we'll put that as blue. We'll just call it water, W. And I'll just put water 2, because I don't know, it's a water droplet. I'm sure there's some scientific thing for that, but I'm not hip on that yet. Now, that will put all that water there. Now, as we work on this, we know that this is going to have a gas coming up. That gas is going to percolate through the waters in here into the system, as we've discussed, in through here and then out. And that will create a specific pressure within here. And as in that the video that I did in, I focus on this section. I really haven't named it yet, so it's hard to refer to. But the water is going to percolate through there, raising the water table inside this part of the system, and playing with how it comes into this room, percolating through that 1-2 inch, about 1 foot 18 inch gap, depending on how you really want to measure it. It is the opening up here. This opening is this section right here. You zoom in on this section, and this is it right here. And up in this section, it's hard to see from here, but there is a break in the rock right there. Comes across from there to there. On this section is where the gas is allowed to flow up. I'm going to tell you it's splurting up with some water, since we have raised the water table on this side of the equation. So it's going to be splurting water up into here. Water is going to be splashing around in there, condensating on the roof, dripping down, raising the water table on this side a little bit because of how it's throwing the water into there, the way it comes into the room, and then it equalizes out. But during that whole equalization process, you are skewing the averages. So the water on this side of the equation is always, because of the mixture and how it's happening, it's a real-time mixture constantly going on, is always going to have the math so that on this side of the system, the water is a tiny bit higher and is going to put a tiny bit extra pressure on there. Now, I know you're going to say, oh, really? You're talking about a mile in size. Yeah, I'm talking a mile in size. Well, when you're taking into account a reservoir, an inch in size at the spillway is taken into account. Okay, so don't harp on me for a little bit here. It goes down into the system, and when it goes down into the system, we are going to feed off of here. It actually goes down, and it does a little jackknife thing on purpose to keep the gases that are flowing to flow out and not to come into this side of the system. This side of the system will be completely wet. Now, ground level, let's go ahead and put ground level. We'll go ahead and put ground level right here. Ground level, as we know, I didn't do it well there, but ground level is 60 feet on this side. So let's not take this number into account, because otherwise, honestly, this would be all chicken. If I was to draw this to scale, this would all be chicken stuff. This would be way down here. Everything in here takes only the bottom 20% of the structure. Do you get that? It's all squished down into the bottom here. So that's why these numbers here, are not linear. They're logarithmic. Yes. Anyway, so within here, I'll tell you what I'm planning, and I'm going to draw this and then squish it because I got more room to work here. But this kind of has to be stretched out to draw it. Comes into this area. This is where we have our anode. And an anode should be red, right? Anode. Okay, this is our anode. No, actually, since it's bleeding oxygen, it should be green. That's our anode. That's where it touches Earth. Everything else is in a bath of limestone. Comes over here. We have what they like to call the dead end shaft. which is fine. They don't really point out to you, but you can see it in the video, the GoPro video I reference, which you can get at GoPro2015.greatgazapyramid.com. That it actually comes down, and at the end, it goes down to about 80% of its size. And it does it that way, kind of like one of those square Torx type bit that you have for machining school tools on your porta potties and stuff. Anyway, now we are constructing it that way, not from some weird spiritualistic type scenario, but we are doing that because we want to, the gas that's going to come out of here is going to fill this room, and it's going to bubble out of the system. It's going to bubble out of there into here, which is why there was the little niche on the wall, but we'll get into that later. It's going to bubble into here, and it's going to bubble out. Now when it bubbles out, this corner right there is specifically engineered so that it's shaped like so. And there's a tooth about 6 feet from the edge so that we can mathematically actually calculate this. We know the width of the ceiling. We know that it's pretty dang smooth from this area over. This, and this area is all stucco-y. I get into why in my system down under videos. I'm just going through the system quickly. You can just watch the system grow. So this is going to allow an oxygen bubble to seat in here and then grow across the ceiling area. This oxygen bubble will grow and grow and grow and grow. And if you notice in here, the roof line, it's actually like that, so that once this grows here, it will bubble out, and when it bubbles out, this oxygen will release, water will come in, creating the water hammer, the reason why John Cadman found evidence of cavitation. That shock wave is going to echo through the system, be focused down into here, where it's going to get into here. I believe we're going to find that this is very well engineered, that I think we're going to get a nice... Anyway, that's my theory. I'm sticking with that one. Oh, and this isn't all smooth. It actually is rippled. And it's actually not completely rippled. It's more like a teardrop, like that. And when we look into it, that probably will... Oh, and you can also see evidence of this. If you look at the photos from the 1800s where there are piles of dirt, like right there. That is the value of the shock wave, or the frequency of the shock wave. And then in here, they're actually a lot closer together, like every 18 inches, where here they're like every 4 feet. Actually, yeah, they were like every 4 or 5 feet. The exact numbers, I wish somebody could look at the photos and get exact numbers, because since it's there, it's evidence, it pretty much is rock solid, you know, rock solid. You can marry it up and tell where they were against the actual measurement of the system, and we can guess based on the volume and the weights that we're talking about exactly how heavy and how much water displacement we are actually toying with. And you know, eventually all this information, if I don't get it into CAD, I will get it into AI, and it will help me generate an answer. So anyway, we have brought the system down there, and I'm not going to redraw this right now. You just saw it, so we can remember that. We go up to ground level. Ground level. This alcohol hangs out on the board too long. This is the grotto. That comes from the lower section. Now this was also going to saturate with water, so please pretend all this is filled with water. Now up here, the grotto's a pretty magical room. We're just going to keep that as the entrance into the room. Now, the entrance into the room on one side is actually a little bit lower, the entrance that comes in, so it actually comes up about 6 inches. Now that 6 inches, half a foot, I think I know they like the foot measurement, but let's just, because I got to draw this, on the inside, when you look at the picture on the inside of the room, which luckily, thanks to modern, I don't think I printed it, so go to photos.greatgizapyramid.com. But here is the room we're looking at in question. Oh, and this is not my drawing, somebody else did it, so you can see how the drawing is, and you can find these photos at photos.greatgizapyramid.com too. But we're looking at this room right here, right now, and the way it functions. And I want to just go over this really quickly because each one of these I can make a lot of detail in. But the water has to come up into the room, and then there's a little wall on the other side. And there's a wall they had to break into that would have come up right above it. So what this is doing is it's making the liquid that's coming into this room have to come up, and then it breaks its pressure because the waters within the room are at a new pressure bubble, because they had to bubble up into the room a little bit to break that pressure bubble to spill over into here. And they're new water. They're still water. They're still, in some cases, connected. At some points, they are still connected as the water raises and lowers, but the pressures in here can't echo back into that room. So when we generate gas in this room, which this room is going to be the cathode, this room is going to bleed the hydrogen, and that hydrogen is what is then brought up to the top of the system and brought in through the area. I know it comes into the area above the king's chamber. Chris Dunn points out that there's much evidence of seeds and shells and dust that they can't account for. That is brought up with the updraft of the gas. And as the gas comes into the room and expands out, the impurities fall out of the gas onto the floor. That's fine. Those gases come from the impurities within the water. Now, some of those gases still work into the system because we find them within the Queen's chamber when they emptied it out, that black soot that they found, which was the same impurities, only cooked to hell. And we'll get into how and why as we continue. We then are going to take that gas, bring it up to the top, and it's going to come down. I'll just go real quick. I don't want to have to draw everything all over again. I already have it right here. It's going to come basically down through the system because you're going to rejoin the hydrogen gas with just air. Air, normal stuff, air. The oxygen is vented out this way, and it is a waste product. They don't need the oxygen side of the water. They want the hydrogen side of the water. The hydrogen is brought up to the top, mixed together with ambient air. 21% oxygen. Oh, thank you. And 78%, 79% nitrogen, and a bunch of other stuff, including carbon dioxide, which should make Al Gore happy because it's all burnt together. It becomes water droplets with some impurities from the air and other stuff that are naturally brought into the system. We don't have little screens and hosiery on there to keep all the bug carcasses out. Well, they may not be bug carcasses when they come in, but they come in, get turned into water, brought down through the system. Now, if we just do that, and let that occur day in and day out, day in and day out, day in and day out, not anyone, but anyone who's homeschooled, or anyone who went to like the Montessori schools will tell you, hey, you do that enough, you're going to get not depleted uranium. You're going to get deuterium. No matter how hard you try not to, it's going to happen. Now, the deuterium is part of what the system is kind of looking for, and you have to appreciate their knowledge of doing that. This is like a big pachenga game for water, and depleted uranium is what pools into here. I guess that goes behind it, so I did it that way intentionally. When we look at the switches over here, they actually work in conjunction, and I discussed that with my, I guess I call it the system within. Got the system down under, system within, joke on Australia. System within, how the switches here are going to work in conjunction with what we already talked about, the switches. When I say switches, I mean as the water level recedes and raises. As the water level in this room raises, it chokes off the amount of oxygen that can be vented out, because you're cutting off, you're making it harder for it to push through. Making it fight against more water. Not more water in here, more water through that one opening. Raising the water pressure, pushing, I'd love to put this into a CAD and play with it. You know, add a little bit more air coming up, add a little bit, well, the water's stagnant. The water's stagnant. That's the one thing that stays the same. The air pressure itself of the gases coming out and the volume of that gas coming out is what dictates how much water and at what pressure this system rides. And it's this, I kind of look at this whole system when I was working back with the lasers, how we had it floated on an air table. This right here is like your little air table switch when you get into it. This is controlling that area there, the wings on that butterfly, are controlling all of the pressures within the entire system. If this blows, this releases, you know, all those pressures release. This whole stack of cards comes tumbling down because it all rides on that. And I'm going to suggest to you they do it again kind of in this section here, where it's riding on that stack of cards when it's, I'm jumping ahead. It's hard when you don't know the whole system for me to try to explain it to you, which is why it's getting me difficult trying to work it through. So let's get back to this. Now this switch here in this room, they say that there are holes drilled within the southern wall. Now I know of 2 of the holes for sure. There may be 3, but there's at least 2. They say holes. I'm not the one who makes that up. One of them is up at up in the upper room, where the upper room comes down a little bit below the floor level. You're going to put a hole there. That is going to ensure that no liquid can get into there, because it can't get up. If we put a hole over here on the top side where it goes up and comes back down, the liquid can't ever bridge that, because water can't go higher than that source. Remember, we're breaking the gap there. Now the other one is actually within the water line, and it is dictated by the square within the room here. Now this room is also long, just like this area is long, and I'm going to suggest to you this area, its length from that tooth in the wall to where it zigzags in the niche there, that is going to be, I believe, 60 cubits to the millimeter in length. So it is 60 1/800ths of a second in length as the sun traverses the surface. Now I'm going to let you think about why I know it's that number later. This one also has a length which is actually quite long. I draw it as a little square there, but it is actually about 18 feet long too. Now when we get into the non-existent communication later, and we talk about that little pamphlet that I suggested you look at, where qubits are based on the speed of the traversing sun above our head. And the foot is a unit of measurement. So one is a unit of time, or referencing time. The other one is referencing length. And when we keep that in mind, and you also keep in mind everywhere where there is a circle represents pressure, and everywhere where it is squared represents volume. And they are, for the most part, consistent, and in some cases you might think they're trying to represent, based on something, well, in a different, everything, I have not found where it's not consistent. You may want it to be somewhere, but that the communication they're referring to is somewhere else. Like here, they put the square here, and they put the circle over here. Now the circle here is going to be let's give this stuff number. This is ground level, so that's 60. It has to go, now ground level, according to this, ground level is the roof line of here, as I understand it. Although it really almost doesn't matter as long as whatever the elevation is here marries the elevation in there. If they don't, we have a problem, because it is designed so that when on this side of the equation a gas is exuded out of here, and I'm going to suggest you it flip-flops back and forth, and I'll show you the switch. The oxygen is going to come up into here, and it's going to build a back pressure, because when the water fills here, and it will, based on its weight, push up on here, pushing the air pressure of pounds per square foot. We are putting oxygen into here, putting pressure down on there, bringing it down till it actually gets to the point where it works in conjunction with this, where it's going to lower the water table down a little bit. And as it lowers the water table down a little bit, it actually is going to break that connection between the waters within structure A and making this pool shorted via that conduit with the waters in structure B, not primarily the waters in structure A. Get that? I'm showing you how it's doing it so you understand. You can teach this to your teacher when they try to tell you about kings and pharaohs and crap. You can tell them, it's a big, huge science project. We can build it in the science lab. The seniors can figure this out. We just need a bunch of plexiglass and time to build it. Anyway, so when it gets down, it can't go any lower than that, because as this is exuding oxygen, we're going to get into this, it breaches that point, and when it breaches that point, I don't yet comprehend why, but it's going to switch because the flow of electrons, and it's going to start bleeding hydrogen. And actually, that, when it bleeds hydrogen, is when I believe it actually lowers the water table, because the oxygen is going to bleed, and as it does that, because of the way this conduit is, and it is here and it is to the top of the square on the other side, as the oxygen pushes its way down, this conduit, which is between the two of them, filled with water, it will break. Now it's only about a foot over the quarter-mile distance, but as it pushes down, it will break that circuit. That is when the energies, which were flowing one direction, can no longer flow that direction. That's when this converts to pushing hydrogen, and when it starts pumping out hydrogen, it will then bring the water table down. I don't believe, in my understanding, and I'm glad to be corrected, that hydrogen has pushing power on water. That's, help me. I don't have a laboratory to play with this, and I don't really trust everything I don't trust everything I read. I'd rather see physical experiments. I'd rather play with the gas myself, but I don't see too many people playing with this. Anyway, that will bring the water table within this system right here, just within this room and this room. We'll bring the water table down a little bit, which will then play with more switches. Now, all of this is playing with pressures, and at some point when we look at all the math, it is playing with the other two steps within the within this way here, because that room, when you look at it, just like all the other rooms, it comes out like so, and then it goes down to connect with the outside world. This is all behind that one wall. Let's see if I do this right. The entranceway is kind of up into here, and that is so the waters can spill down as the gas comes up, and they're adding a little bit of tension there. This shorts with the waters on the outside. The waters on the outside are only yod tall, and you know that's a blow up of that. Okay, that's what we're looking at now. As these are playing their pressure game bubbles, they're going to bounce pressures around, and this whole system is designed to respond to. It is very beautiful. It is designed to respond to other reactions that are occurring a quarter mile away. Do you not yet have appreciation for this? I continue. Within here, I'm not going to draw it. You can pull it up. You can find pictures of it yourself. Maybe I can pull it up if I can find a picture real quick. There. This is a cheesy picture. Very cheesy. There's so many mistakes on this. I'm sometimes embarrassed to pull it up. But we're going to talk about this area in here. This area, get these pens out of the way. This area here, that is designed for condensation. And if you look at it, that whole area there is below the elevation of the pool within, I didn't even get to it on this chart yet, but above the water level, let me get this out of the way. Is the Queen's Chamber hallway thing they like, and we also have the Grand Gallery. It's actually more like that. Comes down. Queen's Chamber. That. Okay. Step. This actually is way off on scale, because this is only like 10% of that whole thing. But what we're gonna, oh, and then you do have the hole in here that they've since filled in, and the area they like to call the niche, which I'm highly exaggerating here its size, but you get the idea. So the waters that fall into here, like I said, they're playing the pachanga game. The heavy waters are actually taunted to pool into there, and taunted not to flow back through the system, but some do, and some escape, and that's why this whole containment system is up there to catch them. But the waters that are in here will never exceed the like 2 or 3 inches above the floor line are going to be the heavy water, where you see that lip just before it goes down. And then you notice in this wall, about 6 inches up, is another spillway that goes in. They like to cover it by a grate that spills over to go back, that actually comes down. So this actually would go up over there, not over there. But the waters in here, the light water, which will ride just below the floor line of the tail of the niche, those will make sure that in the other side, this whole section over here is below that elevation. There's the tooth that comes up, over, and this comes down, and this is this section here, as we discussed.
Are you down here?
And if you remember, I said I'd be recording. I texted you, come down quietly. You're welcome to watch, but please.
I didn't even hear you. I brought you your coffee.
Thank you.